Hello, good morning and afternoon, and whenever you find this. We're getting back into this interesting Tesla read here. The problem of increasing human energy with special references to the harnessing of the sun's energy by Nikola Tesla. So, this time we're getting into the third problem. How to increase the force accelerating the human mass, the harnessing of the sun's energy. Juicy. Okay. Of the three possible solutions of the main problem of increasing human energy, this is by far the most important to consider, not only because of its intrinsic significance, but also because of its intimate bearing on all the many elements and conditions which determine the movement of humanity. In order to proceed systematically, it would be necessary for me to dwell on all those considerations which have guided me from the outset in my efforts to arrive at a solution, and which have led me, step by step, to the results I shall now describe. As a preliminary study of the problem of analytical investigation, such as I have made, of the chief forces which determine the onward movement, would be of advantage, particularly in conveying an idea of that hypothetical velocity, which, as explained in the beginning, is a measure of human energy. But to deal with this specifically here, as I would desire, would lead me far beyond the scope of the present subject. Suffice it to state that the resultant of all these forces is always in the direction of reason, which therefore determines, at any time, the direction of human movement. This is to say that every effort which is scientifically applied, rational, useful, or practical, must be in the direction in which the mass is moving. The practical, rational man, the observer, the man of business, he who reasons, calculates, or determines in advance, carefully applies his effort so that when coming into effect, it will be in the direction of the movement, making it thus most efficient. And in this knowledge and ability lies the secret of his success. Every new fact discovered, every new experience or new element added to our knowledge and entering into the domain of reason affects the same and therefore changes the direction of movement, which, however, must always take place along the resultant of all those effects which, at the time, we designate as reasonable, that is, self preserving, useful, profitable, and practical. These efforts concern our daily life, our necessities and comforts, our work and business, and it is these which drive man onward. Boom! Hey, cool gamer, welcome in. But looking at all this busy world about us, on all this complex mass as it daily throbs and moves, what is it but an immense clockwork driven by a spring? In the morning, when we rise, we cannot fail to note that all the objects about us are manufactured by machinery. The water we use is lifted by steam power. The trains bring our breakfast from distant localities. The elevators in our dwellings and our office buildings, the cars that carry us here, are all driven by power. In all our daily errands and in our very life pursuit, we depend upon it. All the objects we see tell us of it. And when we return to our machine made dwelling at night, lest we should forget it, all the material comforts of our home, our cheering stove and lamp remind us of how much we depend on power. And when there is an accidental stoppage of the machinery, when the city is snowbound, or the life sustaining movement otherwise temporarily arrested, we are affrighted to realize how impossible it would be for us to live the life we live without motive power. Motive power means work. To increase the force accelerating human movement means, therefore, to perform more work. Hey, Tanya, welcome. So we find that the three possible solutions of the great problem of increasing human energy are answered by the three words food, peace, work. Many a year I have thought and pondered, lost myself in speculations and theories, considering man as a mass moved by a force, viewing his inexplicable movement in the light of a mechanical one, and applying the simple principles of mechanics to the analysis of the same until I arrived at these solutions, only to realize that they were taught to me in my early childhood. These three words sound the keynotes of the Christian religion. Their scientific meaning and purpose now clear to me, food to increase the mass, peace to diminish the retarding force, and work to increase the force accelerating human movement. Boom. These are the only three solutions which are possible of that great problem, and all of them have one object, one end, namely to increase human energy. When we recognize this, we cannot help wondering how profoundly wise and scientific and how immensely practical the Christian religion is, and in what a marked contrast it stands in this respect to other religions. It is unmistakably the result of practical experiment and scientific observation, which have extended through the ages, while other religions seem to be the outcome of merely abstract reasoning. Nope, I don't agree. Work, untiring effort, useful and accumulative, with periods of rest and recuperation aiming at higher efficiency, is its chief and ever recurring command. Thus, we are inspired both by Christianity and science to do our utmost toward increasing the performance of mankind. This most important of human problems I shall now specifically consider. Dang, dude, I just am now very curious about his other study into religions for him to say that so boldly. The source of human energy, the three ways of drawing energy from the sun. First, let us ask, whence comes all the motive power? What is the spring that drives all? We see the ocean rise and fall, the rivers flow, the wind, rain, hail, and snow beat on our windows. The trains and steamers come and go. We hear, I think it's supposed to be HEAR. We hear the rattling noise of carriages, the voices from the street. We feel, smell, and taste. And we think of all this. And all this movement, from the surging of the mighty ocean to that subtle movement concerned in our thought, has but one common cause. All this energy emanates from one single center, one single source, the sun. The sun is the spring that drives all. The sun maintains all human life and supplies all human energy. Another answer we have now found to the above great question. To increase the force accelerating human movement means to turn to the uses of man more of the sun's energy. What about the moon, though, too? It's like saying one element is more important than another element. It's not. I'm not. I mean, the sun is super important. I believe. I agree. I'm just saying. We honor and revere those great men of bygone times whose names are linked with immortal achievements, who have proved themselves benefactors of humanity. The religious former with his wise maxims of life, the philosopher with his deep truths, the mathematician with his formal, it says FORMUL, I think it's supposed to be formulation because then it has a dash. The physicist with his laws, the discoverer with his principles and secrets wrested from nature, the artist with his forms of the beautiful. But who honors him, the greatest of all? Who can tell the name of him? Who first turned to use the sun's energy to save the effort of a weak fellow creature? That was man's first act of scientific philanthropy, and its consequences have been incalculable. Oh, excuse me. From the very beginning, three ways of drawing energy from the sun were open to man. The savage, when he warmed his frozen limbs at a fire kindled in some way, availed himself of the energy of the sun stored in the burning material. When he carried a bundle of branches to his cave and burned them there, he made use of the sun's stored energy transported from one to another locality. When he set sail to his canoe, He utilized the energy of the sun applied to the atmosphere or the ambient medium. There can be no doubt that the first is the oldest way. A fire found accidentally taught the savage to appreciate its beneficial heat. He then very likely conceived of the idea of carrying the glowing members to his abode. Finally, he learned to use the force of a swift current of water or air. It is characteristic of modern development that progress has been effected in the same order. The utilization of the energy stored in wood or coal, or generally speaking, fuel, led to the steam engine. Next, a great stride in advance was made in energy transportation by the use of electricity, which permitted the transfer of energy from one locality to another without transporting the material. But as to the utilization of the energy of the ambient medium, no radical step forward has yet been made known. Hey, Kimbo, welcome. A little cough real quick here. Bonjour! Hey, welcome in. Awesome to see you this morning. Some juicy reading. The ultimate results of development in these three directions. Oh, wait. Is that where I am? But as to the utilization of energy in the ambient medium, no radical step forward has yet been made known. Yes. The ultimate results of development in these three directions are first, the burning of coal by a cold process in a battery. Second, the efficient utilization of the energy of the ambient medium. And third, the transmission without wires of electrical energy to any distance. In whatever way these results may be arrived at, their practical application will necessarily involve an extensive use of iron, and this invaluable metal will undoubtedly be an essential element in the further development along these three lines. If we succeed in burning coal by a cold process and thus obtain electrical energy in an efficient and inexpensive manner, we shall require in many practical uses of this energy electric motors, that is, iron. If we are successful in deriving energy from the ambient medium, we shall need both in the obtainment and utilization of the energy machinery, again, iron. I'm thinking of the Baghdad battery. It's cool. That's probably the first one though, the passive. Okay, so if we realize the transmission of electrical energy without wires on an industrial scale, we shall be compelled to use extensively electric generators. Once more, iron. Whatever we may do, iron will probably be the chief means of accomplishment in the near future, possibly more so than in the past. How long its reign will last is difficult to tell, for even now aluminum is looming up as a threatening competitor. But for the time being, next to providing new resources of energy, it is of the greatest importance to making improvements in the manufacture and utilization of iron. Great advances are possible in these latter directions, which, if brought about, would enormously increase the useful performance of mankind. I'm surprised that he didn't get into hey, Dean, welcome in. That he didn't get into imaginings of new materials being found and invented, because, I mean, that has happened, especially in conjunction with electronics. Like, yeah. Great possibilities offered by iron for increasing human performance. Enormous waste in iron manufacture. This is the next section. Iron is by far the most important factor in modern progress. It contributes more than any other industrial product to the force accelerating human movement. So general is the use of this metal, and so intimately is it connected with all that concerns our life, that it has become indispensable to us as the very air we breathe. Its name is synonymous with usefulness. But however great the influence of iron may be on the present human development, it does not add to the force urging man onward nearly as much as it might. First of all, its manufacture, as now carried on, is connected with an appalling waste of fuel, that is, waste of energy. Then again, only a part of all the iron produced is applied for useful purposes. A good part of it goes to create frictional resistances, while still another large part is the means of developing negative forces greatly regarding human movement. Thus, the negative force of war is almost wholly represented in iron. It is impossible to estimate with any degree of accuracy the magnitude of this greatest of all retarding forces, but it is certainly very considerable. If the present positive impelling force due to all useful applications of iron be represented by 10, for instance, I should not think it exaggeration to estimate the negative force of war, with due consideration of all its regarding influences and results, say, at 6. On the basis of this estimate, the effective impelling force of iron in the positive direction would be measured by the difference of these two numbers, which is 4. But if through the establishment of universal peace, the manufacture of war machinery should cease, and all struggle for supremacy between nations should be turned into healthful, ever active and productive commercial competition, then the positive impelling force due to iron would be measured by the sum of those two numbers, which is 16. That is, this force would have 4 times its present value. This example is, of course, merely intended to give an idea of the immense increase in the useful performance of mankind which would result from a radical reform of the iron industries supplying the implements of warfare. A similar estimable advantage in the saving of energy available to man would be secured by obviating the great waste of coal, which is inseparably connected with the present methods of manufacturing iron. Obviating. Let's look it up. Posthumous. Obviating. Obviate. Remove. Hey, did I turn my sound down or something? No. It's not working. I'm pretty sure that's how you say obviate, though. Obviate. I mean, I could totally be wrong, but avoid, prevent, remove, obviate. Cool. I'm right up in here.
Obviate.
Well, that was super delayed. Weird. My internet is so slow. I wonder if I'm chopping up. Dude, seriously, my internet has just like gone to the dial-up ages. I don't get it. My phone too. My phone has shit service now that I've upgraded. I'm pretty happy about that. It's just like I'm buffering 24/7. It's super cool. Thanks 5G and T-Mobile. Salty. I'm salty. Where's that word? Obviate. Oh, it's the very first sentence. Okay. Jesus. Pardon me. A similar inestimable advantage in the saving of energy available to man would be secured by obviating the great waste of coal, which is inseparably connected with the present methods of manufacturing iron. In some countries, such as Great Britain, the hurtful effect of this squandering of fuel are beginning to be felt. The price of coal is constantly rising, and the poor are made to suffer more and more. Though we are still far from the dreaded exhaustion of the coal fields. I mean, what cyclical problems, cyclical things, it's just a play. Now it's, the gas. It's just the same thing. It's the same sort of emotional play. Okay. Though we are still far from the dreaded exhaustion of coal fields, philanthropy commands us to invent novel methods of manufacturing iron, which will not involve such barbarous waste of this valuable material from which we derive at present most of our energy. It is our duty to coming generations to leave this store of energy intact for them, or at least not to touch it until we shall have perfected processes for burning coal more efficiently. Those who are coming after us will need fuel more than we do. We should be able to manufacture the iron we require by using the sun's energy without wasting any coal at all. As an effort to this end, the idea of smelting iron ores by electric currents obtained from the energy of falling water has naturally suggested itself to many. I have myself spent much time in endeavoring to evolve such a practical process, which would enable iron to be manufactured at small cost. After a prolonged investigation of the subject, finding that it was profitable to use the currents generated directly for smelting the ore, I devised a method which is far more economical. Hmm. Love you, Tanya. Have a good one. Okay, sweet. I'm glad it's still solid. Economical production of iron by a new process. The industrial project, as I worked it out 6 years ago, contemplated the employment of the electric currents derived from the energy of a waterfall, not directly for smelting the ore, but for decomposing water of a preliminary step. To lessen the cost of the plant, I proposed to generate the currents in exceptionally cheap and simple dynamos, which I designed for this sole purpose. The hydrogen liberated electrolytic in the electrolytic decomposition was to be burned or recombined with oxygen. Electrolytic. I gotta look it up. Electrolytic is of or relating to, I thought so, electrolysis. Yeah, or an electrolyte. Yeah. Salt, water, electrolysis, the charge. Shit. Dude. Man, Jay used to always talk about electrolysis. Hmm. Hmm. Okay. Wrong one. Back to YouTube's. Where am I? I don't know. Electrolytic. Am I down in here? Yeah. Balls. There's all these words are so tiny. It seems to make it a lot more difficult for me to find my place. I don't know. Maybe I'm just making excuses. The hydrogen liberated in the electrolytic decomposition was to be burned or recombined with oxygen, not with that from which it was separated, but with that of the atmosphere. Thus, very nearly the total electrical energy used up in the decomposition of the water would be recovered in the form of heat resulting from the recombination of the hydrogen. This heat was to be applied to the smelting of ore. The oxygen gained as a byproduct of the decomposition of the water I intended to use for certain other industrial purposes, which would probably yield good financial returns, inasmuch as this is the cheapest way of obtaining this gas in large quantities. In any event, it could be employed to burn all kinds of refuse, cheap hydrocarbon, or coal of the most inferior quality, which could not be burned in air or be otherwise utilized to advantage, and thus again a considerable amount of heat would be made available for the smelting of the ore. To increase the economy of the process, I contemplated, furthermore, using an arrangement such that the hot metal and the products of combustion coming out of the furnace would give up their heat upon the cold ore going into the furnace, so that comparatively little of the heat energy would be lost in the smelting. I calculated that probably 40,000 pounds of iron could be produced per horsepower per annum by this method. Annum, annual? Liberal allowances were made for those losses which are unavoidable, the above quantity being about theoretically half of that theoretically obtainable. Easy for me to say. Relying on this estimate and on practical data with reference to a certain kind of sand ore existing in abundance in the region of the Great Lakes, including the cost of transportation and labor, I found in some localities iron could be manufactured in this manner cheaper than by any of the adopted methods. This result would be obtained all the more surely if the oxygen obtained from the water, instead of being used for smelting of ore, is assumed, should be more profitably employed. Any new demand for this gas would secure a higher revenue from the plant, thus cheapening the ore. This project was advanced merely in the interest of industry. Someday, I hope, a beautiful industrial butterfly will come out of the dusty and shriveled chrysalis. Pigeon sneeze. Aw, that does sound cute. The production of iron from sand ores by a process of magnetic separation is highly commendable in principle, since it involves no waste of coal. But the usefulness of this method is largely reduced by the necessity of melting the iron afterward. As to the crushing of iron ore, I would consider it rational only if done by water power, or by energy otherwise obtained without consumption of fuel. The electrolytic cold process, which could make it possible to extract iron cheaply and also to mold it into the required forms without any fuel consumption, would, in my opinion, be a very great advance in iron manufacture. In common with some other metals, iron has so far resisted electrolytic treatment, but there can be no doubt that such a cold process will ultimately replace in metallurgy the present crude method of casting, and thus obviating the enormous waste of fuel necessitated by the repeated heating of metal in the foundries. Up to a few decades ago, the usefulness of iron was based almost wholly on its remarkable mechanical properties, but since the advent of the commercial dynamo and electric motor, its value to mankind has been greatly increased by its unique magnetic qualities. As regards the latter, iron has been greatly improved of late. The signal process began about 13 years ago when I discovered that in using soft Bessemer steel instead of wrought iron, as then customary, in an alternating motor, the performance of the machine was doubled. I brought this fact to the attention of Mr. Albert Schmid, to whose untiring efforts and ability is largely due the supremacy of American electrical machinery, and who was then superintendent of an industrial corporation engaged in this field. Following my suggestion, he constructed excuse me. Whew. Following my suggestion, he constructed transformers of steel, and they showed the same marked improvement. The investigation was then systematically continued under Mr. Schmid's guidance, the impurities being gradually eliminated from the steel, which was only such in name, for the reality it was pure soft iron, and soon a product resulted which admitted of little further improvement. The coming of age of aluminum, doom of the copper industry, the great civilizing potency of the new metal. With the advances made in iron of late years, we have arrived virtually at the limits of improvement. We cannot hope to increase very materially its tensile strength, elasticity, hardness, or malleability, nor can we expect to make it much better as regards its magnetic qualities. More recently, a notable gain was secured by the mixture of a small percentage of nickel with the iron. But there is not much room for further advance in this direction. New discoveries may be expected, but they cannot greatly add to the valuable properties of the metal, though they may considerably reduce the cost of manufacture. The immediate future of iron is assured by its cheapness and its unrivaled mechanical and magnetic qualities. These are such that no other product can compete with it now. But there can be no doubt that, at a time not very distant, iron, in many of its now uncontested domains, will have to pass the scepter to another. The coming age will be the age of aluminum. It is only 70 years since this wonderful metal was discovered by Wohler, and the aluminum industry, scarcely 40 years old, commands already the attention of the entire world. Such rapid growth has not been recorded in the history of civilization before. Not long ago, aluminum was sold at the fanciful price of $30 or $40 per pound. Today, it can be had in any desired amount as for many cents. Oh, for as many cents. What is more, the time is not far off when this price, too, will be considered fanciful, for great improvements are possible in the methods of its manufacture. Most of the metal is now produced in the electric furnace by a process combining fusion and electrolysis, which offers a number of advantageous features, but involves naturally a great waste of the electrical energy of the current. My estimates show that the price of aluminum could be considerably reduced by adopting in its manufacture a method similar to that proposed by me for the production of iron. A pound of aluminum requires for fusion only about 70% of the heat needed for melting a pound of iron, and inasmuch as its weight is only about one third of that of the latter, a volume of aluminum four times that of ore could be obtained from a given amount of heat energy. But a cold electrolytic process of manufacture is the ideal solution, and on this I have placed my hope. The absolutely unavoidable consequence of the advancement of the aluminum industry will be the annihilation of the copper industry. They cannot exist and prosper together, and the latter is doomed beyond any hope of recovery. Even now, in its cheaper Even now, it is cheaper to convey an electric current through aluminum wires than through copper wires. Aluminum castings cost less, and in many domestic and other uses, copper has no chance of successfully competing. A further material reduction of the price of aluminum cannot but be fatal to copper. But the progress to the former will not go on unchecked, for as it ever happens in such cases, the larger industry will absorb the smaller one. The giant copper interests will control the pygmy aluminum interests, and the slow pacing copper will reduce the lively gait of aluminum. This will only delay, not avoid, the impending catastrophe. Hmm. I don't know. Copper still has its place, but maybe not in industry. Aluminum, however, will not stop at drowning copper. Aluminum, however, will not stop at drowning copper. Before many years have passed, it will be engaged in a fierce struggle with iron, and in the latter, it will find an adversary not easy to conquer. The issue of the contest will largely depend on whether iron shall be indispensable in electric machinery. This the future alone can decide. Yeah, because I mean, aluminum is awesome, and it's like, yeah, it melts so quickly. Isn't it wild that we could like make our own aluminum bars just by gathering up cans? I watched a YouTube guy do that. It was so cool. He just he just collected tons of aluminum cans and then he made his own aluminum bars. And like watching him take all the slag off the top from the print and everything was cool. It was like in his garage. Well, sort of. I mean, it was right outside of his garage. He was outside. Okay, so before many years have passed, it will be engaged in a fierce struggle with iron, and in the latter, it will find an adversary not easy to conquer. The issue of the contest will largely depend on whether iron shall be indispensable in electric machinery. This the future alone can decide. The magnetism is exhibited in iron, as exhibited in iron, is an isolated phenomena in nature. What it is that makes this metal behave so radically different from all other metals is in this respect, has not yet been ascertained, though many theories have been suggested. As regards magnetism, the molecules of the various bodies behave like hollow beams partly filled with a heavy fluid and balanced in the middle in the manner of a seesaw. Huh. Evidently, some disturbing influence exists in nature which causes each molecule, like such a beam, to tilt either one way or the other way. If the molecules are tilted one way, the body is magnetic. If they are tilted the other way, the body is non magnetic. But both positions are stable, as they would be in the case of the hollow beam, owing to the rush of the fluid to the lower end. Wow. Now, the wonderful thing is that the molecules of all known bodies went one way, while those of iron went the other way. This metal, it would seem, has an origin entirely different from that of the rest of the globe. It is highly improbable that we shall discover some other and cheaper material with which will equal or surpass iron in magnetic qualities. Hmm. That's awesome. We had a guy that used to come and pick up our oil for a while too. Unless we should make a radical departure in the character of the electric currents employed, iron will be indispensable. Yet the advantages it offers are only apparent. So long as we use feeble magnetic forces, it is by far superior to any other material. But if we find ways of producing great magnetic forces, then better results will be obtainable without it. In fact, I have already produced electric transformers in which no iron is employed, and which are capable of performing 10 times as much work per pound of weight as those of iron. The results, the result is attained by using electric currents of a very high rate of vibration produced in novel ways instead of the ordinary currents now employed in the industries. I have also succeeded in operating electric motors without iron by such rapidly vibrating currents, but the results so far have been inferior to those obtained with ordinary motors constructed of iron, although theoretically the former should be capable of performing incomparably more work per unit of weight than the latter. But the seemingly insuperable difficulties which are now in the way may be overcome in the end, and then iron will be done away with, and all electric machinery will be manufactured of aluminum, in all probability at prices ridiculously low. There was insuperable. I'm keeping my thumb right here. Insuperable. I gotta look that up. Right? He must be busy. Insuperable. Of a difficulty or obstacle impossible to overcome.
Insuperable.
Insuperable. Okay. Insuperable. Adjective. Of a difficulty or obstacle impossible to overcome. Insuperable financial problems. Okay, cool beans. Oh, whoa. Okay. So, the seemingly insuperable difficulties which are now in the way may be overcome in the end. Okay. This would be a severe, if not fatal, blow to iron. In many other branches of industry, as shipbuilding or wherever lightness of structure is required, the progress of the new metal will be much quicker. For such uses, it is eminently suitable and is sure to supersede iron sooner than later. It is highly probable that in the course of time we shall be able to give it many of those qualities which make iron so valuable. While it is impossible to tell when this industrial revolution will be consummated, there can be no doubt that the future belongs to aluminum, and that in times to come it will be the chief means of increasing human performance. It has, in this respect, capacities greater by far than those of any other metal. I should estimate its civilizing potency at fully 100 times that of iron. This estimate, though it may astonish, is not at all exaggerated. First of all, we must remember that there is 30 times as much aluminum as iron in bulk, available for the uses of man. This in itself offers great possibilities. Then again, a new metal is much more easily workable, which adds to its value. In many of its properties, it partakes of the character of a precious metal, which gives it additional worth. Its electric conductivity, which for a given weight is greater than that of any other metal, which would be alone sufficient to make it one of the most important factors in future human progress. Its extreme lightness makes it far more easy to transport the objects manufactured. By virtue of this property, it will revolutionize naval construction, and in facilitating transport and travel, it will add enormously to the useful performance of mankind. But its greatest civilizing property will be, I believe, in a real travel, which is sure to be brought about by means of it. I believe in a rial travel, RIAL. I gotta look it up. Real.
Rial.
Rial. The basic monetary unit of Iran and Oman, equal to 100 dinars in Iran and 1,000 biaza in Oman. I wonder if that's what he means.
Rial.
The basic monetary of Iran and Oman. I don't know. But its greatest civilizing property will be, I believe, in a real travel, which is sure to be brought about by means of it. I don't get it. Telegraphic instruments will slowly enlighten the barbarian. Electric motors and lamps will do it more quickly, but quicker than anything else, the flying machine will do it. By rendering travel ideally easy, it will be the best means for unifying the heterogeneous elements of humanity. As the first step toward this realization, we shall produce a lighter storage battery or get more energy from coal. Efforts toward obtaining more energy from coal, the electric transmission, the gas engine, and the cold coal battery. This is the next section. I remember that at one time I considered the production of electricity by burning coal in a battery as the greatest achievement toward the advancing civilization, and I am surprised to find how much the continuous study of these subjects has modified my views. It now seems to me that to burn coal, however efficiently, in a battery would be a mere makeshift, a phase in the evolution towards something much more perfect. After all, in generating electricity in this manner, we should be destroying material. And this would be a barbarous process. We ought to be able to obtain the energy we need without consumption of material. But I am far from underrating the value of such an efficient method of burning fuel. At the present time, most motive power comes from coal, and either directly or by its products, it adds vastly to human energy. Unfortunately, in all the process now adopted, the larger portion of the energy of the coal is uselessly dissipated. The best steam engines utilize only a small part of the total energy. Even in gas engines, in which, particularly of late, better results are obtainable, there is still a barbarous waste going on. In our electric lighting systems, we scarcely utilize 1/3 of 1%, and in lighting by gas, a much smaller fraction of the total energy of coal. Considering the various uses of coal throughout the world, we certainly do not utilize more than 2% of its energy theoretically available. The man who should stop this senseless waste would be a great benefactor of humanity, though the solution he would offer could not be a permanent one, since it would ultimately lead to the exhaustion of the store of material. Efforts toward obtaining more energy from coal are now being made chiefly in two directions: by generating electricity and by producing gas for more motive power purposes. In both of these lines, notable success has already been achieved. I watched this documentary a couple years ago. I can't even remember what it was called, but it was talking about all of the green energy that we use, and how basically just to create the green energy that we use, that we end up using more fossil fuels and more energy, and that more waste is created just by creating solar panels and shit like that. It sort of broke my heart that it would just be more efficient to burn coal than to burn all the coal that it takes to make a or burn whatever. I don't know. I don't know the specifics. Like I said, it was years ago. But my point remains. The advent of the alternating current system of electric power transmission marks an epoch in the economy of energy available to man from coal. Evidently, all electrical energy obtained from a waterfall, saving so much fuel, is a net gain to mankind, which is all the more effective as it is secured with little expenditure of human effort, and as this most perfect of all known methods of deriving energy from the sun contributes in many ways to the advancement of civilization. But electricity enables us also to get from coal much more energy than was practical in the old ways. Instead of transporting the coal to distant places of consumption, we burn it near the mine, develop electricity in the dynamos, and transmit the current to remote localities, thus affecting a considerable saving. That's smart. Instead of driving the machinery in a factory in the old wasteful way of belts and shafting, we generate electricity by steam power and operate electrical motors. In this manner, it is not uncommon to obtain 2 or 3 times as much effective motive power from the fuel, besides securing many other important advantages. It is in this field, as much as in the transmission of energy to great distance, that the alternating system, with its ideally simple machinery, is bringing about an industrial revolution. But in many lines, this progress has not been yet fully felt. For example, steamers and trains are still being propelled by the direct application of steam power to shafts or axles. A much greater percentage of the heat energy of the fuel could be transformed into motive energy by using, in place of the adopted marine engines and locomotives, dynamos driven by specially designed high pressure steam or gas engines, and by utilizing the electricity generated for the propulsion. A gain of 50 to 100% in the effective energy derived from the coal could be secured in this manner. It is difficult to understand why a fact so plain and obvious is not receiving more attention from engineers. The ocean steamers, such as improvement, in ocean steamers, such an improvement would be particularly desirable, as it would do away with noise and increase materially the speed and the carrying capacity of the liners. Right? What the heck? Okay, the straws, Genevieve got me. Still more energy is now being obtained from coal by the latest improved gas engine, the economy of which is, on the average, notably twice that of the best steam engine. The introduction of the gas engine is very much facilitated by the importance of the gas industry. With the increasing use of the electric light, more and more of the gas is utilized for heating and motive power purposes. In many instances, gas is manufactured close to the coal mine and conveyed to distant places of consumption, a considerable saving both in cost of transportation and in utilization of the energy of the fuel being thus affected. In the present state of the mechanical and electrical arts, the most rational way of deriving energy from coal is evidently to manufacture gas close to the coal store and to utilize it, either on the spot or elsewhere, to generate electricity for industrial uses in dynamo driven by gas engines. The commercial success of such a plant is largely dependent upon the production of gas engines of great nominal horsepower, which, judging from the keen activity in this field, will soon be forthcoming. Instead of consuming coal directly, as usual, gas should be manufactured from it and burned to economize energy. But all such improvements cannot be more than passing phases in the evolution towards something far more perfect, for ultimately we must succeed in obtaining electricity from coal in a more direct way, involving no great loss of heat energy. Whether coal can be oxidized by a cold process is still a question. Its combination with oxygen always involves heat, and whether the energy of the combination of the carbon with another element can be turned directly into electrical energy has not yet been determined. Under certain conditions, nitric acid will burn the carbon, generating an electric current, but the solution does not remain cold. Other means of oxidizing coal has been proposed, but they have offered no promise of leading to an efficient process. My own lack of success has been complete, though perhaps not quite so complete as that of some who have perfected the cold coal battery. This problem is essentially one for the chemists to solve. It is not for the physicist who determines all his results in advance so that when the experiment is tried, it cannot fail. Chemistry, though a positive science, does not yet admit of a solution by such positive methods as those which are available in the treatment of many physical problems. The result, if possible, will be arrived at patent trying patent trying rather than through deduction or calculation. The time will soon come, however, when the chemist will be able to follow a course clearly mapped out beforehand, and when the process of his arriving at a desired result will be purely constructive. The cold coal battery would give a great impetus to electrical development. It would lead very shortly to a practical flying machine and would enormously enhance the introduction of the automobile. But these and many other problems will be better solved and in a more scientific manner by a light storage battery. So, this bit that he said about physicalness, I don't like it. It's all good. Yeah, we still have to be open minded. Everyone's unique. But right, there are methods. So let's see here. 1 hour. Energy from the medium, the windmill, and the solar engine. Motive power from terrestrial heat. Electricity from natural sources. Besides fuel, there is abundant material from which we might eventually derive power. An immense amount of energy is locked up in limestone, for instance, and machines can be driven by liberating the carbonic acid through sulfuric acid or otherwise. I once constructed such an engine, and it operated satisfactorily. But whatever our resources of primary energy may be in the future, we must, to be rational, obtain it without consumption of any material. Long ago, I came to this conclusion, and to arrive at this result only two ways, as before indicated, appeared possible: either to turn to use the energy of the sun stored in the ambient medium, or to transmit through the medium the sun's energy to distant places from some locality where it was obtainable without consumption of material. At the time, I at once rejected the latter method as entirely impractical and turned to examine the possibilities of the former. It is difficult to believe, but it is nevertheless a fact that since time immemorial, man has had at his disposal a fairly good machine, which has enabled him to utilize the energy of the ambient medium. This machine is the windmill. I thought he was going to say the human body. Contrary to popular belief, the power obtainable from wind is very considerable. Many a deluded inventor has spent years of his life in endeavoring to harness the tides, and some have even proposed to compress air by tide or wave power for supplying energy, never understanding the signs of the old windmill on the hill, as it sorrowfully waved its arms about and bade them stop. The fact is that a wave or tide motor would have, as a rule, but a small chance of competing commercially with the windmill, which is by far the better machine, allowing a much greater amount of energy to be obtained in a simpler way. Wind power has been, in old times, of inestimable value to man, if for nothing else but for enabling him to cross the seas. And it is even now a very important factor in travel and transportation. But there are great limitations in this ideally simple method of utilizing the sun's energy. The machines are large for a given output, and the power is intermittent, thus necessitating the storage of energy and increasing the cost of the plant. A far better way, however, to obtain power would be to avail ourselves of the sun's rays, which beat the earth incessantly and supply energy at a maximum rate of over 4 million horsepower per square mile. Bam! Wow! Holy majoli! I didn't know. Although the average energy received per square mile in any locality during the year is only a small fraction of that amount, yet an inexhaustible source of power would be opened up by the discovery of some efficient method of utilizing the energy of the rays. Man, it makes me think of gardens, right? The only rational way known to me at the time when I began the study of this subject was to employ some kind of heat or thermodynamic engine driven by a volatile fluid, evaporate in a boiler by the heat of the rays. But closer investigation of this method and calculation showed that, notwithstanding the apparently vast amount of energy received from the sun's rays, only a small fraction of that energy could be actually utilized in this manner. Furthermore, the energy supplied through the sun's radiations is periodical, and the same limitations as in the use of the windmill I found to exist here also. After a long study of this mode of obtaining motive power from the sun, taking into account the necessarily large bulk of the boiler, the low efficiency of that heat engine, the additional cost of storing the energy, and other drawbacks, I came to the conclusion that the solar engine, a few instances excepted, could not be industrially exploited with success. Another way of getting motive power from the medium without consuming any material would be to utilize the heat contained in the earth, the water, or the air for driving an engine. It is a well-known fact that the interior portions of the globe are very hot, the temperature rising, as observations show, with the approach to the center at the rate of approximately 1 degree Celsius for every 100 feet of depth. The difficulty of sinking shafts and placing boilers at depths of, say, 12,000 feet, corresponding to an increase in temperature of about 120 degrees Celsius, are not insuperable, and we could certainly we could certainly avail ourselves in this way of the internal heat of the globe. In fact, it would not be necessary to go to any depth at all in order to derive energy from the stored terrestrial heat. The superficial layers of the earth and the air strata close to the same are at a temperature sufficiently high to evaporate some extremely volatile substances, which we might use in our bodies and which we might use in our boilers instead of water. There is no doubt that a vessel might be propelled on the ocean by an engine driven by such a volatile fluid, no other energy being used but the heat abstracted from the water. But the amount of power which would be obtained in this manner would be, without further provision, very small. Electricity produced by natural causes is another source of energy which might be rendered available. Lightning discharges involved great amounts of electrical energy, which we could utilize by transforming and storing it. Some years ago, I made known a method of electrical transformation which renders the first part of this task easy, but the storing of the energy, the lightning discharges, will be difficult to accomplish. As is well known, furthermore, that electric currents circulate constantly through the earth, and that there exists between the earth and any air stratum a difference of electrical pressure, which varies in proportion to the height. In recent experiments, I have discovered two novel facts of importance in this connection. One of these facts is that an electric current is generated in a wire extending from the ground to a great height by the axial, and probably also by the translatory movement of the earth. No appreciable current, however, will flow continuously in the wire unless the electricity is allowed to leak out into the air. Its escape is greatly facilitated by providing at the elevated end of the wire a conducting terminal of great surface with many sharp edges or points. We are thus enabled to get a continuous supply of electrical energy by merely supporting a wire at a height, but unfortunately, the amount of electricity which can be so obtained is small. Code, welcome! Oh my gosh, welcome! So good to see you. Happy Wednesday. Oh, right. This is, yeah. The second fact, which I have ascertained, is that the upper air strata are permanently charged with electricity opposite to that of the Earth. Ooh. So at least I have interpreted my observations from which it appears that the Earth, with its adjacent insulating and outer conducting envelope, constitutes a highly charged electrical condenser containing, in all probability, a great amount of electrical energy which might be turned to the uses of man if it were possible to reach with a wire to a great altitude. What a thought. Like a straw. It is possible and even probable that there will be, in time, other resources of energy opened up, of which we have no knowledge now. We may even find ways of applying forces such as magnetism or gravity for driving machinery without using any other means. Such realizations, though highly improbable, are not impossible. An example will best convey the idea of what we can hope to attain and what we can never attain. Imagine a disk of some homogeneous material. I just need to look it up to make sure I'm saying it right. Every time I come across it, I stumble. Tom, welcome in. Homogeneous.
Homogeneous.
Homogeneous. Okay.
Homogeneous.
Cool. Of the same kind, alike. Consisting of parts of all the same kind. Cool. Oh, balls. Damn it. Am I down in this one? Son of a gun. There it is. Imagine a disk of some homogeneous genius material turned perfectly true and arranged to turn in frictionless bearings on a horizontal shaft above the ground. This disk, being under the above conditions perfectly balanced, would rest in any position. Now, it is possible that we may learn how to make such a disk rotate continuously and perform work by the force of gravity without any further effort on our part. But it is perfectly impossible for the disk to turn and to do work without any force from the outside. If it could do so, it would be what is designed scientifically as a pendulum, perpetuum mobile, a machine creating its own motive power. Dude, I've spent hours imagining this. I just got like magnets. To make the disk rotate by the force of gravity, we have only to invent a screen against this force. By such a screen, we could prevent this force from acting on one half of the disk, and the rotation of the latter would follow. At least we cannot deny such a possibility until we know exactly the nature of the force of gravity. Suppose that this force were due to a movement comparable to that of a stream of air passing from above toward the center of the earth. The effect of such a stream upon both halves of the disk could be equal, and the latter would not rotate ordinarily. But if one half should be guarded by a plate arresting the movement, then it would turn. Dude, I don't know. Mystical, welcome in. Awesome-o. The departure from known methods, possibility of a self-acting engine or machine, inanimate yet capable, like a living being, of deriving energy from the medium, the ideal way of obtaining motive power. When I began the investigation of the subject under consideration, and when the preceding or similar ideas presented themselves to me for the first time, though I was then unacquainted with a number of the facts mentioned, a survey of the various ways of utilizing the energy of the medium convinced me, nevertheless, that to arrive at a thoroughly satisfactory practical solution, a radical departure from the methods then known had to be made. The windmill, the solar engine, the engine driven by terrestrial heat, had their limitations in the amount of power obtainable. Some new way had to be discovered which would enable us to get more energy. There was enough heat energy in the medium, but only a small part of it was available for the operation of an engine in the ways then known. Besides, the energy was obtainable only at the very slow rate. Clearly, then, the problem was to discover some new method which would make it possible both to utilize more of the heat energy of the medium and also to draw it away from the same at a more rapid rate. I was vainly endeavoring to form an idea of how this might be accomplished when I read some statements from Carnot and Lord Kelvin, then Sir William Thomson, which meant virtually that it is impossible for an inanimate mechanism or self-acting machine to cool a portion of the medium below the temperature of the surrounding and operate by the heat abstracted. These statements interested me intensely. Evidently, a living being could do this very thing, and since the experiences of my early life, which I have related and convinced me that a living being is only an automaton, or otherwise stated, a self-acting engine, I came to the conclusion that it was possible to construct a machine which would do the same. As the first step towards this realization, I conceived the following mechanism. Imagine a thermopile consisting of a number of bars and metal extending from the earth to the outer space beyond the atmosphere. The heat from below, conducted upward along these metal bars, would cool the earth or the sea or the air according to the location of the lower parts of the bars. And the result, as is well known, would be an electric current circulating in those bars. The two terminals of the thermopile could now be joined through an electric motor, and theoretically, this motor would run on and on until media below would be cooled down to a temperature of the outer space. This would be an inanimate engine, with all evidence which to all evidence would be cooling a portion of the medium below the temperature of the surrounding and operating by the heat abstracted. Huh. Diagram B, obtaining energy from the ambient medium. So here's another terrible blurry picture for you. Where is it? Oh no, have I been going in and out of focus? I hope not. Sometimes I forget to check that. Okay. Haha, awesome. Oh my gosh, that's so cool, Code. It's good food for thought. Okay, so focus all the way in for this terribly blurry picture. That's good. Okie doke. Diagram B, obtaining energy from the ambient medium. A, medium with little energy. B, and B, ambient medium with much energy. O, path of the energy. Okay. But it was not possible to realize a similar condition without necessarily going to a. Oh, but was it possible? Mother of pearls. But was it not possible to realize a similar condition without necessarily going to a height? Conceive, for the sake of illustration, a cylindrical enclosure T, as illustrated in diagram B, such that energy could not be transferred across it except through the channel or path O, and that by some means or other. In this enclosure, a medium were maintained, which would have little energy, and that on the outer side of the same, there would be the ordinary ambient medium with much energy. Under these assumptions, the energy would flow through the path O, as indicated by the arrow, and might then be converted on its passage into some other form of energy. The question was, could such a condition be attained? Could we produce artificially such a sink for the energy of the ambient medium to flow in? Suppose that an extremely low temperature could be maintained by some process in a given space. The surrounding medium would then be compelled to give off heat, which could be converted into mechanical or other form of energy and utilized. By realizing such a plan, we should be enabled to get any point of the globe. We should be able to get at any point of the globe a continuous supply of energy day and night. More than this, reasoning in the abstract, it would seem possible to cause a quick circulation of the medium and thus draw the energy at a very rapid rate. I feel like I want to show you this diagram again, just so I can point out you can see the A, the B, the O with the arrow off to the left-hand side. A's up top, the B's are on the side, the T, the O. Okay. Awesome. Here then was an idea which, if realizable, afforded a happy solution of the problem of getting energy from the medium. But was it realizable? I convinced myself that it was so in a number of ways, of which one is the following. As regards heat, we are at a high level, which may be represented by the surface of a mountain lake considerably above the sea, the level of which may mark the absolute zero of temperature existing in an interstellar space. Heat, like water, flows from high to low level, and consequently, just as we can let the water of the lake run down to the sea, so we are able to let heat from the Earth's surface travel up to the cold region above. Heat, like water, can perform work in flowing down, And if we had any doubt as to whether we could derive energy from the medium by means of a thermopile, as before described, it would be dispelled by this analogy. Analog. Analogue. Let's look it up. And I'm at the very bottom of the page. Analog. Louge. Relating to or using signals or information represented by a continuously variable physical quantity, such as spatial position, voltage, etc. What? A person or thing seen as comparable to another. That's a noun, but adjective. Relating to or using signals or information represented by a continuously variable physical quantity. A continuously variable physical quantity, such as spatial position, voltage, etc. I don't understand. Relating to or using signals or information represented by a continuously variable physical quantity, such as spatial position, voltage, etc. Yep, I keep reading it and I keep not understanding. I don't get it. Something that is similar or comparable to something else, either in general or in some specific detail. Something that is analogous to something else, historical analogs to the current situation, an aspirin analog. Something that is similar or comparable to something else, either in general or in some specific detail. The bottom of the page I said. Heat, like water, can perform work in flowing down. And if we had any doubt as to whether we could derive energy from the medium by means of a thermopile, as before described, it would be dispelled by this analog. Well, I'm moving forward. I don't understand. But can we produce cold in a given portion of the space and cause the heat to flow continually? To create such a sink or cold hole, as we might say, in the medium, would be equivalent to producing in the lake a space either empty or filled with something much lighter than water. This we could do by placing in the lake a tank and pumping all the water out of the latter. We know then that the water, if allowed to flow back into the tank, would theoretically be able to perform exactly the same amount of work which was used in pumping it out, but not a bit more. Consequently, nothing could be gained in this double operation of first raising the water and then letting it fall down. This would mean that it is impossible to create such a sink in the medium. But let us reflect a moment. Heat, though following certain general laws of mechanics, like a fluid, is not such. It is energy which may be converted into other forms of energy as it passes from a high to low level. To make our mechanical analogy complete and true, we must, therefore, assume that the water, in its passage to the tank, is converted into something else, which may be taken out of it without using any, or by using very little, power. For example, if heat be represented in this analogy by the water of the lake, the oxygen and hydrogen composing the water may illustrate other forms of energy into which the heat is transformed in passing from hot to cold. If the process of heat transformation were absolutely perfect, no heat at all would arrive at the low level, since all of it would be converted into other forms of energy. Corresponding to this ideal case, All the water flowing into the tank would be decomposed into oxygen and hydrogen before reaching the bottom, and the result would be that water would continually flow in, and yet the tank would remain entirely empty. The gases formed escaping. We would thus produce, by expending initially a certain amount of work to create a sink for the heat, or respectively, the water to flow in, a condition enabling us to get any amount of energy without further effort. This would be an ideal way of obtaining motive power. We do not know of any such absolutely perfect process of heat conversion, and consequently, some heat will generally reach the low level, which means to say, in our mechanical analog, that some water will arrive at the bottom of the tank and a gradual and slow filling of the latter will take place, necessitating continuous pumping out. But evidently, there will be less to pump out than flows in, or in other words, less energy will be needed to maintain the initial condition that was developed by the fall. And this is to say that some energy will be gained from the medium. What is not converted in flowing down can just be raised up with its own energy, and what is converted is clear gain. Thus, the virtue of the principle I have discovered resides wholly in the conversion of the energy on the downward flow. Well, I feel really irritated because I don't understand that. I didn't pick it up. And I was trying really hard. That makes me feel so irritated. B, our stopping takes some time. Head. I just kept getting more. I really did understand. Doesn't make any sense. Okay. No, but thank you very much for hanging out with me, and I'm glad we got more in through this. Maybe one more or two more of these. Probably one more. But I'm so close. 120. Yeah, one more. I had to know. So I apprehend that one. Okay. So thank you. Thank you. So I don't live. I might go live because it's an earlier show, Burger. So I should be home by 10 tonight. Or a like fucking dream. But if I don't, Ooh, shitty connection. Okay, off I go now. Thank you. Bye.